All right, so today we're taking a look at how we can actually multiply out and then go backwards to factor problems that look like these, where you got numbers in front of the x's. That's kind of going to be our big goal today. And so what we're going to be doing is we're going to be using something that I call the box method. Basically, it's just a way of organizing your thoughts to do some guess and check kind of stuff. And so we're going to start by seeing how the box works forward before we can use it going backwards, which is our main goal. So in order to fill in this box, basically we're multiplying each row header by its column header. So like for this box right here, I'm going to multiply the 3x by the 2x. So 3 times 2 gives me 6, and then the x times the x gives me x squared. So that first box ends up equaling x squared, or 6x squared. All right, next up, let's go to the box next to it right over here. So notice for that box, I got to multiply the 3x by the 5. So 3 times 5 gives me 15, and then there's just the one x there, so it stays in x. Okay, the next box, let's go to this one. So in this case, we're doing 2x times a negative 4. When we do 2x times negative 4, that gives me a negative 8x. And then for the last box, we're going to do negative 4 times 5, which gives me a negative 20. So the way this ends up being helpful to us is we can now go ahead and add those pieces together in order to see what that's going to come out as with a multiplied version. And so I end up basically doing 6x squared plus 15x minus 8x minus 20. And you notice we have a couple like terms there that we can add together. Those x's in the middle. And so we go ahead and combine those. So we get 6x squared, and then the 15x minus 8x gives me 7x. It's positive, so it's still a plus. And then minus 20 hanging on the end. And then this is your answer. And this is just using the box method just to organize our thoughts. It's just a visual representation of what we're doing with it. Now, having walked through that first one together, go ahead and now use that picture to do this one. Multiply this one out. And yes, please use the box because, again, we're kind of building up some knowledge and some skills so that we can use it backwards here in a minute. All right, and so in this case, this is the box we should end up with. And then we go ahead and we add the pieces together. So the 4x squared stays a 4x squared. I can go ahead and add the two like terms, which are those. So 32 and then negative 1, that gives me a positive 31x. And then the minus 8, it just stays a minus 8. So that's your final answer, the way we expand it out. Right, now we're going to start transitioning to where we can start using it at least partly backwards. Here I've given you part of the box filled in on the outside and part of it filled in on the inside. Copy that down and then see if you can figure out what are the numbers going to be along the outside here, and then what are the numbers going to be on the inside here. All right, so in order to do that, I'm going to start by trying to figure out what this number is that's going to be hanging out outside the box up here. So in order to figure out what that is, I have to say 6x times what would give me the 6x squared. So what would that have to be? Yep, it's got to be x. So then this is going to be an x there. And then I do the same thing for the 12x, where I'm saying 6x times what would give me 12x. What would that be? 2. Now that I know those two numbers around the outside, I can fill in the other two that are inside the box as well. So I do the 7 times x to get 7x. And then I do the 7 times the 2 to get 14. And that completes the whole box. And then we can see both a factored form and an expanded form in this picture. Because we have a factored form around the outside. If I read across the top, I have x plus 2. If I read down the left side, I have 6x plus 7. As I look at the inside, I have 6x squared, and then I combine those like terms, so that ends up being plus 19x, and then plus the 14. So the box really is a way of visually representing both our factored form and our expanded form together. All right, then next up, here you have the entire inside filled in. Please fill in the outside. That would give us that result on the inside. All right, so in order to be able to do this, what I'm going to do is I'm going to basically look to see what can I factor out of each row and out of each column. I'm going to start by looking at the rows for no particular reason. You just got to choose one to go with. All right, let's start with the first row. 8x squared and 12x. What can I divide both of those by? Well, the 8 and the 12, I can divide both of those by 4. And notice they also both have x's in them. An x squared and an x. That means I could not only factor out a 4, but I could factor out a 4x. And now I can repeat the process with the second row as well. What can I factor out of both of those terms? 3, right? And so that then can tell me what does the left side give me. And then we can proceed back to the column headers the same way that we did before when we had part of it. So we can go ahead and do 4x times what gives me 8x squared? Gotta be 2x, yeah. And so that gives me 2x, and then we can check ourselves. Does 2x times 3 give me 6x? Yes, it does, so that's good. That means we're on the right track. And then 4x times what would give me 12x? 3. And again, we can check ourselves. Does 3 times 3 give me that 9? Yes, it does. And so then that is the correct outside of that box filled in, which means we just factored that polynomial that we had represented on the inside as well. Because really that tells me that that whole thing factored to be 2x plus 3 from the top, and then 4x plus 3 down the side. All right, so having done that one, you've kind of seen the basic process. Now go ahead and do that with this problem, please. Fill in the outside of that box. All right, and so to start doing that, in order to factor out here, I do look to see either I pick rows or columns, up to you about which one you want to start with, and I see what can I factor out of each either row or column. Now, I tend to intuitively think I actually want to look at the columns first, but I'm going to stick with rows here just for fun. In this case, notice I can divide both of those by x, and that's the only thing I can divide both of those by. So this then has to be an x. Which means if that's going to be an x, notice that means this has to be a 10x because I'm multiplying 10x squared. And then along the bottom row, the 20x and the 6, what can I divide both of those by? Just a 2, right? And so that ends up giving me a 2. And 2 times what gives me the 6 here? Well, that's got to be a 3. And so again, that's telling me the factored form that went with the expanded form that was represented inside there. And that's the idea that we're going to be using as we go forward, actually use this box representation as a way to factor some slightly tougher quadratics. So let's actually now walk through the whole process of using that box method. So please write down this equation and then set up a box where we're going to be writing the stuff inside of it. And we're going to walk through this one step by step. All right, now when setting up our box for this, we'll always end up putting in the first two boxes the same way. In the top left box, we're going to put the first term every single time. In the bottom right box, we're always going to be putting the last term. So when I say first term, that means the x squared term. When I say the last term, I mean the constant term. And so the first thing in your box is it should look like this. The 11x squared goes in the top left, and the 6 goes in the bottom right here. And once we've written that in, our goal is still to figure out what are the numbers going to be around the outside. Now, you'll notice, though, that we're missing some critical information here. We're missing what these two boxes are. This is where we are going to enter a little bit of a guess and check process, because we know that those two boxes are going to have to add to 35x. But we don't know exactly what they are yet, and it's going to take a little bit of trial and error to see what is actually going to work. So, this is our basic setup, and this is what we're working with. Now I'm going to lead you through that process about how do we do that guess and check part. All right, now with this particular setup, and for most of them that you see here at the start, I'm going to be starting you off with at least one number of those two that are already in the box being prime, because it makes it a little easier to find the possibilities. So which one's prime here? The 11, right?
Oh, wait a minute.
The 11 is a prime number, which tells me that the only way I can get that 11 is 1 times 11. So to get this 11x squared, I know in order to get x squared, I have to have x and x. And then one of those is going to have to be a 1, and one of them is going to have to be an 11. Doesn't matter which one you choose to be which at this point. So I'm just going to put the 11 on the row. Now there's a little bit of a guess and check element here, because we then have to see, okay, what's that going to give me? And for the 6, I'm not quite sure what it's going to be yet. It could be 6 and 1, or it could be 1 and 6. Those will give us different numbers, notice, because it's going to change which one gets multiplied by the 11. Or, instead of 6 and 1, it could be 3 and 2. Or, of course, 2 and 3. And our goal is, again, to figure out which ones are going to make that add to 35x. Now, as you do more of these, you get faster at it, and you start being able to go to your answer right away. But, of course, I want to show you how to really use that guess and check possibility on it, and how to go through the whole process. So I'm just going to start by guessing some stuff. And I'm going to go ahead and start the way that I first wrote it down. I'm going to try the 6 and the 1. Now, you don't necessarily want to write this down in your box quite yet, maybe next to it, something like that. Another great tool and technique is write down your box and pen, and then you can write down your guesses in pencil, and that way when you erase your guesses, you don't erase your whole box. A couple little tricks that you'll learn over time as you do more of these, what works best for you. So what I do now is I try and see what would that multiply to. So like the 6 times 11 would give me 66, that's 66x. 1 times x gives me x. Does that add to 35? Nope. So then that means that is not my winning combination. Okay, so now I try switching it. So try switching the 1 and the 6. Okay, so now I do 1 times 11x, that's going to give me 11x. Then I do x times 6, that gives me 6x. Does that add to 35x? No. That means I just ruled out the 6 and the 1, because I tried it both ways, so I know it's not 6 and 1. Well, the nice part about 6 is there's only one other way to get it. 2 and 3. The only question is which order it goes in. So I'm just trying one order here. So 2 times 11x will give me 22x. 3 times x gives me 3x. Does that add to 35x? No, which means I've had some really bad luck. I have tried every combination but one, and I'm betting that last one's going to work then, because it's the only one that could work left. All right, we multiply that. 3 times 11x gives me 33x. X times 2 gives me 2x. Does that add to 35x? Yes, thankfully. And so then this is what my box ends up looking like in the end. Now, because I can now see what that box looks like, I can now tell what the factored form is, because I can read it across the top for one factor, and then I can read it down the left side for the other factor. So this then is our actual factored form. We've now factored the quadratic that had the number in front of x squared. Notice how this is different from the problems you've seen before? In every problem you've seen before, either there was no number in front of x squared, in which case you could just do add 2 multiply 2, or you're able to divide that number out and then use add 2 multiply 2. We can't do either of those here because we cannot divide everything through by the 11. And that's why we need this box method. And again, remember, box method is just a way of visually organizing our information as we do a guess and check. Because that's really what it is guess and check. And just like when you first started factoring quadratics way back when with add to the middle number, multiply to the last number, it was slow at first, and then it got faster. These will be slow at first, and then they'll get faster as well. So I want you to practice one of these on your own. Please use this method, use the box to factor this quadratic. All right, and to make sure that you are on the right track here, this is where you should be starting. The first term, remember, goes in the first box. The last term goes in the last box. And then you're adding diagonally to your middle number. All right, so from here now, we need to now start guessing some of the pieces. Now, the easiest thing to guess here really is the 7, because the only way to get 7 is to do 7 times 1. Now, in this particular case, one of them is going to have to be negative, but I'm not going to worry about the negative quite yet. I'm just going to use the 7 and the 1 at the moment. All right, now I start guessing, how do I get the 9x squared? Well, of course, since it has x squared in it, I know that I'm going to have an x and an x. I know that much. So the stuff I've written in already, this is pretty much the stuff I can know for sure. Now I actually got to do a little bit more guessing. Now to get the 9, there's a couple different possibilities. Either I can do 9 and 1, or I can do 3 and 3. And we're just going to guess about which one we're going to do first. Now I tend to like to start with numbers that are kind of closer to each other. It's just my personal preference. So I'm going to start with the 3 and the 3. So let's try that. So I go 3 here and I go 3 here. If I do that, I now multiply through to see what those diagonal boxes will get me. So 3x times 7 gives me 21x. 3x times 1 gives me 3x. Now remember, one of those is going to be negative. If I make one of those negative, am I going to be able to get a 2 in any way? No. Okay, so my 3's didn't work. But the nice thing about starting with 3 and 3 is I don't have to worry about switching the order of them, right? It doesn't matter which one is 3 because they're both 3. All right, so now I'm going to try the 9 and the 1. Now, if you start getting your instincts built up on these, you'll actually be able to know ahead of time which one should be 9 and which one should be 1. Because if I'm going to try to have the two numbers to be just 2 apart here, well, I don't really want to do 9 times 7 then, because that would give me a really big number. That would tell me to put the 9 here. And yes, the 1 would be in front of the x, but of course I don't need to write 1x, I can just leave that as x. Alright, so let's multiply those now. The 9x times 1 will give me 9x. The 7 times the x gives me 7x. If I make one of those negative, can I get a 2 out of that? Yeah. So which one needs to be negative? The 7 needs to be negative. Yeah, because I need to have more positives than negatives. And so if that negative 7x is there, that means the 7 up here needs to be the negative. And so that's how we can kind of piece together what goes where. So this is then what your final box ends up coming out looking like. And then you read it across the top to see your first factor, and then you read it down the left side to see your other factor. So your final answer ends up being 9x minus 7 times x plus 1. And again, remember, this box, all it is a guess and check method, building up our instincts to be able to see what will probably go where. It's just, I call it box method just because it's a nice way to organize it, but it's just a guess and check method. So later on, as you get into pre-calc stuff like that, you'll be factoring quadratics. There's multiple methods. You're just using guess and check here.